Hi, here's an example on how to determine the molecular ionic and net ionic equation for a precipitation problem. So here we have one example problem of a problem here where we've got a solution of sodium chloride and silver nitrate. So we've got two solutions of NaCl and silver nitrate that are mixed. And so the question is, will it precipitate form? And if so, write then the balanced molecular ionic and net ionic equations. And if no reaction, we write NR for no reaction. So let's start with writing out the molecular equation that happens right here. Determine first of all if a precipitate will form. So we need to put this word equation right here. Sodium chloride, we know that is NaCl, and silver nitrate, so silver 1 nitrate, so that will be AgNO3, and this is aqueous, plus sodium chloride, produce to form. So then these precipitation reactions usually follow some kind of double displacement pattern right here. So we can think about this, that the silver will pair with the chloride and the nitrate right here will pair with the sodium ion. So it's kind of like a double displacement reaction right here. And so we can think about this as some kind of A, B plus C, D will make some products Ca, or the other way around, it doesn't really matter, plus BD. And so we see right here, we get with this crossing over of the compounds right here. So we need to evaluate now which of these will be insoluble. So let's look at the possible products that are being formed. So we can form silver chloride plus the other one would be then sodium nitrate, NaNO3. Now we need to look in our solubility table, which of these compounds could possibly be insoluble. So we look and see that the silver chloride would be insoluble. And then this right here, this sodium nitrate, would be soluble. So we use our solubility rules to determine this, and so then we can determine that because this is insoluble, that will be the precipitant. This will precipitate out of solution. We can also indicate that with a little arrow pointing downward to indicate that this is crashing out of solution. It's not necessary. You can do one or the other. Putting in the S is usually enough, but a lot of chemists like to overemphasize with a downward arrow, which is precipitating out of solution. And that means also that this other one right here is soluble, so this one remains aqueous. So now we've written out the formula equation, or the molecular equation, molecular. And next we can write the ionic equation, where we break up all these species into their constituent ions. So then we have silver plus nitrate, and here it is really important to understand the ionic rules that you learned earlier in the preceding chapters, that you know that when you have these word problems that you come up with the right formula for these things. So you know that silver 1 nitrate is not AgN or something like that it is the nitrate ion, and if in doubt, look up your polyatomic ions again, or remember those. So we've got silver nitrate plus sodium ion, Na plus Cl minus, and all of these are aqueous, will form this silver chloride precipitate that we mentioned earlier. And that one we do not write out as ions. This one stays as a solid. These ones are in the liquid, in the solution that we are mixing together, so they exist as ions in the solution. Plus sodium nitrate. And this one right here will be again in solution, Na plus NO3 minus. Plus NO3 minus. Aqueous. So this would be the ionic equation, where we write down all the ionic species except for the one that precipitates. And then the net ionic equation is we cancel out the spectator ions. So again, here we can change the, we can note right here that the spectator ions are this one right here, and this nitrate, they are both on both sides of the equation are. Same thing with the sodium and the sodium. They remain both on the same side of the equation, so we can cancel it out. Net ionic equation is therefore going to be silver, Ag plus, aqueous, plus chloride minus, makes silver chloride solid. That is then our net ionic equation. Thanks for watching. Let's follow and do another example.